Hi guys, in this video I will demonstrate how to um, draw a normal probability curve, where a normal probability curve, what it does is it compares, basically shows you whether your data is normally distributed or not. So what it does is it takes x in the x-axis some sort of theoretical z values, so and on the y-axis usually it is either the actual data or cumulative probability values of your data. Now we do the first one as it's described in your chapter 6 in your book. In chapter 6 there's one graph, graph 6.22, so we will try to replicate that in our Excel exercise here. Now first of all, about data, this is your homework 1 marks, and I can see this is not actually normally distributed. By looking at it's a small sample, you can easily see that it's more likely to be a left skewed, and most of the concentration is on the right hand side, so higher values, I mean, on the higher side of it. So let's start with creating proportions first. Now what it is this. So let's look at this in a graphical draw. So if you, let's assume that there is some sort of standard normal distribution here, and let's assume this is my standard normal distribution, although it doesn't look like. Now what I will create is I create partitions, equally spaced partitions. So I'm going to create this such equally spaced partition. In other words, this distance here between these columns are the same. Oh, in other words, I should say probability values are the same. So area under this, let's say, curve, and area under this curve would be the same as area under this curve and area under this curve. So these are equal valued areas under the curve. Well, my battery is low, so I'll be quick. Now then for each one I calculate z values. Well, I basically locate them from the z table. Now I will not do this in this video, I will just ask Excel to do that. So let's do that. So we'll then these z values will be drawn against y-axis, and y-axis will have our actual data. Right, so that's what we're going to do with the proportions and z value column here in our exercise. So let's go back to our Excel. I have to be quick now, which the time is running. And so proportions, so for that your book, there are a number of ways of creating that, but your book recommends to use this formula. Okay, it's divided by let's say we have a number of data points here. We have our 20, so 20 marks. So I'll just follow the book, and it is n plus 1, so 20 plus 1, close the bracket, equal. Right, this is the probability value up to a certain point here, certain z value. Now this has to be cumulative proportions, so the next one would be the first value plus the next value, next proportion or partition. So it will be first one plus the next partition. As I said, each partition has the same area under the curve, so equals. Now we will extend this to the bottom. Yeah, so we have this cumulative proportions. Now it's also cumulative probabilities, in other words, and we need this. Using this formula allows us not to go infinity, because the normal curve goes actually into infinity on both tails, so it doesn't have some boundaries. So it allows us to avoid that sort of running into infinity series. So if you use a 1 over 20, you will see that you run up to 1 very quickly. So we don't want that as well. Now, next thing is the z values. So we need to create z values for each of these partitions, and we know that z values are calculated using a z formula, but it's going to be tedious if you follow that. Instead, I will ask Excel to calculate that for us. So this would be the function norm sinf, actually. Yeah, that's the one, and it only takes one argument, and that is the probability value, and the probability value here is this one, and enter. Right, this is my z value basically on the left hand side of the distribution. So if you look at the probability distribution function, so this z value is basically is minus 1.66, and area under this from this point onwards, or to the left basically, is equal to 0. Where is my x? Okay, 0.047 apparently, and then in that fashion we'll calculate the remaining z values too. So I'll just do the double click there, and it gives me the z values. You see, this z value is actually a positive of this z value, and this is a normally distributed. Well, if this is data, it would be a normal distributed data basically, but I convert them into z's. Next, now we've got the z values, we've got the marks ascending order. Now we'll plot them. So let's go to chart. Where is my chart builder? So we need the scatter graph. Click first one, and right click, select data, and let's add a series. Is 1, and x values, as I said, they are these expected z values, or theoretical z values I should say they are, and then your marks on the y. So you see that on the y we have the on the x you have your z's, and on y it's the marks. Now you can put a nice title if you want, a QQ plot, and then x values and y labels properly, but I leave it to you because of timing, and I'm running out of battery power now. So click OK. Right, so it looks like it is not normal. As you can see, it's not dots are not lying on a straight line basically, but then we don't need this space here. I mean, this can be removed. So if double click on the y-axis, and let's say minimum start, let's say 60, and we don't need okay, that's fine. 105 should really be 100, but leave it. So yeah, as you can see, what we see here is some sort of a quick rise here, and then slow ascending sort of curve. So we have this curve quickly rising and going descending down, converging to sort of original kind of level here. If you put a line here, you would see that it's actually coming back to that line after quickly going up. Now this is evidence that our data is actually left skew, because theoretically that's how it should be for left skew data. So if you have that data with the line here, and if your this is your y, this is your actual data, and this is your z, then if your data behaves like this, then this is a symptom of left skew basically, right? And if you read the chapter, you will see this as sort of theoretical curve as well. If your data, let's say, plotted in this form, then this is a symptom of or evidence that there is a right skew in the data. Or if your data kind of lies on the straight line, then this is basically an evidence that this data is normally distributed. So as we expected earlier, your marks are actually, well, wait a sec, yeah, your marks are skewed to the left, and well, we have a lot of smart students among ourselves, so that's a good result. And yeah, that's it. I hope it helps you, and you can actually, I mean, do this in Windows, Windows Excel or Mac Excels, because the functions are the same here, and most of them are. I mean, this is the minimum use of functions basically that could be different from Mac version to Windows. So yeah, that's it for now.